All right, here it is. We are continuing. Now listen, we did 1 through 11 in first period today, so that's going to be up to you to go on YouTube if you really need to go over it. I mean, if you look at the test and you're like, I know how to do all that stuff, then you don't have to look at it. But if you need to look over it and review, then go to YouTube. I'll put it on your class, even though I taught it in first period. I'll still put it under your class's, heading or whatever. So hopefully you'll know what to do. Let's see. Let's change a couple things here. All right, we are ready, I think. All right, so I went up to number 11. Actually, I think I did number 12, but I'm going to start at this section right here. So here's what it says. It says determine the value of x so that these two lines right here would be parallel to each other. So let's put some stuff in here. So XL is 3. I think I ended up there. Let me make sure. You know what? I didn't. I'm sorry. It kind of looks like the same picture. That's why I thought this is where we were in the other class, 8 and 9. I think we did 8, but so this is about similar triangles. Remember that chapter? So let's take a look, okay? These two triangles right here are similar to each other. I'll just show you why real quick. Okay, remember if you can just have two angles of one triangle equaling two angles of another triangle, then they're similar. So look, both these triangles, I've got this little tiny triangle and I got this big triangle right here. They both share this angle right here, and they also, look, right there. Everybody see that? So those two angles are equal to each other corresponding. So there's two angles in the small triangle, equal two angles in the big triangle. So those two triangles right there are similar to each other. So if they're similar to each other, we can set up some proportions and all that good stuff. So let's solve for RT. I think in the other class I said instead of calling it RT, let's just call it one letter. Let's just call it A. Is that all right? Whatever you want to call it. So this is what you're going to do. You want to compare A to, what do you think? To 18, right? So let's compare A to 18. But you got to be careful on this. A is the entire side of that big triangle. 18 is the entire side of that particular smaller triangle. They are corresponding to each other, so you got to be careful. A lot of people look at this and say, "Oh, compare A to 18 and then 12 to 24." Okay, I know it is, but I changed it to 18. On the test it says 1.8, but I changed it to 18 because it wasn't supposed to be 1.8. That was a mistake. Even though, anyway, it's 18 now. All right, so it's A over 18 equals, now watch, a lot of people look at this real quick and they say, oh, compare this one to this one, this one to this one. You can't do this because this is an entire side of this triangle, and you're comparing it to the entire side of the smaller triangle. So watch, let's take, I'm not going to use this over here because I don't know what x is just yet. All right, so what I'm going to do though, what is the entire, over here, what is the entire side of this big triangle? No, we just said we can't go 12 over 24. It's got to be 36. I'm comparing, if I go A over 18, I'm comparing the big triangle to the small triangle. What's the whole entire side of the big triangle over here? It's 36. And I compare it to what? The smaller triangle, the side of the smaller triangle, which is 24, correct? Makes sense? So now we just solve for A, and that's pretty easy. Multiply by 18, multiply by 18, and let's just use a calculator for this. So it's 36 times 18 divided by 24, and that's 27. All right, so we said A, but it's RT, isn't it? Which is just 27. Everybody okay with that? That's not so bad, is it? It's a little bit tricky, though, because a lot of people, I bet you, if I took a poll, bet you a bunch of you would probably put 12 over 24 instead of 36 over 24. Okay, that was a little bit tricky right there. All right, let's just get rid of all that. Give myself some more room to write. All right, let's do SV. SV is this one right here. So in order to find the length of SV, I'm going to have to do what? Well, actually, right now, I don't even have to solve for x. I could just find SV, couldn't I? Let's see if I do this right. This is where I can actually compare, even though this is not the whole entire length of the whole triangle. Let's see. I have to double check and see if this is going to work. Let's compare 15 to what? you could compare it to this, or you can compare it to 12, right? So let's go 15 to 12. It's been a while since I've done these, so I got to make sure this works. 15 over 12 is what? 7x minus 9 over 24. So let's see if that works. You could do that. That'd be easier. Exactly right. Now you could do this and it would still work. It should still work. Let's just do this just for fun. Let's see if it works, okay? So, let's just cross multiply. So, what is it? 12 times 7. What's 12 times 7? What? 12 times 7 is 16? 12 times 7 is 16? It's 84. It's 84x minus 12 times 9, which is what? 108? Equals, I don't know what that is. 360? Okay, good. Help me with some math here. Add a 108, so that'd be what? 468? So 84x equals 468, am I right? Divide that by 84.
I'm guessing 83. No.
I'm hoping it's... Well, it's actually, that's what x is going to be. 5.6?
It's 5.57, so...
Is it exactly 5.57?
No, it's...
It just keeps going?
Yeah. So, 5.57 is 5.6.
Let's just keep it 468 divided by 84. I know this is ugly.
That's the answer?
No, it's not the answer. It's x. So yeah, so multiply that by 7. Subtract a 9. I don't think... Shh, just let me think, okay? You keep talking. I'm trying to think, okay?
I'm just trying to do it easier.
Let's see. What did I mess up somewhere? So 468 divided by 84. Multiply that by 7, right? So if I multiply that by 7, that 7 would... Okay, let's see. Let's try. Rachel, I like your way much better, but I started this way. I just want to see if I get the same answer. So 468 divided by 84, all right? And then, so that's what x is, right? Multiply that by 7, and then subtract a 9. And then that should be this side right here. Let's see if that works. 7 goes into 84, what, 12 times? Is that right? What's 468 divided by 12? Does that go even? Somebody tell me. Who's got a calculator? Come on, quick.
Why would the
goodness.
5.6 be much easier?
Because it's not exact answer.
It's 39.
Okay, good. But it's not an exact answer. You keep saying it's easier. Okay, well, 1 plus 1's easier, but that's not the answer to this. Okay?
You're now dismissed.
468, what am I doing? Divided by 12, and that's 39. Good. So 39 minus 9 is what? It's 30. All right? Just like Rachel said it was, and it would have been a lot easier. And I agreed with you. As soon as you showed me that, I agreed that that would be easier, but I just wanted to make sure that that did work. So that does work. If you wanted to go that direction, you feel free to do that, but Rachel said this, which I like. She said, look at the ratio here. Compare it like this, 12 to 24. So this is twice as big as this, isn't it? Well, this has the same ratio, so this has to be twice as big as this. Agreed? So if that's 15, what's this? It's 30. I like that much better. I like that a whole lot better. Don't you? Yep. And I should have seen that right away. For some reason, I went from here to here, and I don't know why. I definitely should have seen 12 and 24, and that's a much better way to do it. Yep. Okay, so that's what SV is equal to. All right, good. All right, let's do this one right here. Number 10, LM. Okay, and that's what we're trying to solve for. That's what we want to find. Let's see. Let's find... Here's the hardest part. It's easy to see that these two relate to each other, the x plus 3 and the x minus 1. Of course, there's really no other numbers here for these to relate to, but if you look at this, this angle and this angle are equal to each other, aren't they? Because they're what? I got parallel lines cut by transversal. They are alternate interior angles, right? So this angle is equal to this angle. So that means 18 is opposite this, 12 is opposite this, so 18 and 12 are corresponding sides, aren't they? So what can you do? You could do a couple things. You could go 18 to 12. They are similar triangles. You could go 18 to 12 equals x plus 3 over x minus 1. Okay, if you wanted to reduce this, it might make your math a little bit easier to begin with. So what goes into both of those? 6 goes into that 3 times, into this twice. So it might be just easier doing it like that, wouldn't you agree? Makes the numbers smaller. So, no, you can't do that, because that's being added and that's being subtracted. So, no, you can't do it. Long story, I'm not going to go through it now. It won't work. So it's 3 times this, which is 3x minus 1, equals 2 times this, which is 2x plus 6. Subtract 2x. Huh? Yeah. Wow. I made a mistake that I always yell at other kids, and I even put parentheses around it so I wouldn't forget to distribute. And I tell people all the time, don't forget to distribute. And look what I did. I forgot. So subtract 2x. Yeah, if you see me make a mistake, definitely point it out. Don't let me keep going. All right, subtract 2x from both sides, and I get x. Add a 3 to both sides, and I get 9. And so x is equal to 9. But that's not my answer, though. They ask you to solve for the length of LM. So basically, it's just 9 plus 3, which is 12. And then that's what that answer is right there. Okay. All right, so let's get rid of some of this stuff. Get rid of that. Okay. No. Look at QP. Now we got to solve for this right here. Oh, we just did it. What did we get x to be? It was 9, right? So 9 minus 1 is 8. That's simple. So you did all the work already. That was easy to find that. All right, now let's go to this one. This is what we were going to do earlier. Now, over here, this is kind of the same thing, really. To tell you the truth, if you look at this, watch. This, they told you that the lines are parallel to each other, so we knew that those segments were in proportion. Okay. On this one right here, they're going to actually, we want to find what x is in order to make this and this parallel. So if the sides are in proportion, then those lengths right there would be parallel to each other. It's kind of the same thing, but backwards. This is kind of like the converse of this. It's not kind of like the converse. It is the converse of that. So let's see what we can do here. Let's change colors. Let's get this green. All right, so here we go. Let's put some numbers in here. XL is 3, so that's 3. YM is 5. LD 9, and MD is x plus 3. And we are trying to find what x is going to equal in order to make this parallel to this. Well, if these are in proportion, then if these segments right there are in proportion, then these two segments right there will be parallel to each other. So we got to put them in proportion, 3 over 9. So watch, this is what? Let's do it like you did, right? This is 3 times as big as this, right? So that means what? This is 3 times as big as this. So what's x plus 3 equal to? What's that whole thing?
15.
It's got to be 15. Okay? So x is what? 12. So that's a nice way to do it. Now sometimes they don't come out nice and beautiful like that. I mean, this could have been like 3 over 10, and you couldn't have said, oh, this is 3 times as big. But in this case, though, it actually does work out real nice. This side right here is 3 times as big as this one, so this has to be 3 times as big as this, so that has to be, this whole thing has to be 15. Well, you had to solve for x, so this x plus 3 is equal to 15, subtract 3, and x is 12. So x equals 12 right there. Does that make sense to you? I hope so. All right, let's get rid of this. I don't have a lot of room to write, so as I do these, oops, let's try this again. All right, let's do that. Get rid of that. Okay. Let's do another one. Use the same color. YM this time is 3. And then LD is 3x plus 1. XL is 4. And MD is x plus 7. All right, this isn't quite as nice as the other one was, but it's fine. Let's see. I got a little space in here, so let's do the writing in here. So you can do it a couple different ways. You can compare this one to this one equals this to this, or you can compare this way to that way. It doesn't make any difference whatsoever. So let's just go top to bottom. So 4 over 3x plus 1 equals... No, you're not. You're not paying attention when you're doing... No, when you're doing that stuff like that, you're not paying attention. Just sit and listen to me, please. 3 over x plus 7. Alright, so that's how we set up our relationships, this to this, this to this, and then we just do the math and solve for x. We'll just do it. So what do we get? 4x plus 28 equals, off the grid here, equals, what is it, 9x plus 3. Subtract 4x from both sides, subtract a 3 from both sides, x is 5. Alright, there you go. Simple as that. Everybody good with that? You can always rewind it, can't you? Alright. One more of these. This was pretty easy. MD, is this one is easy? 5x minus 6. YM is 3. LD, 5x plus 1. Yeah, this is all pretty much the same kind of problem, isn't it? XL is 5. Alright. So, I don't know, just for fun, let's compare this way this time. Okay, we could go either way. We can go here to here or here to here. It doesn't make any difference. So let's go 5 to 3 this time. Equals what? 5x plus 1 over 5x minus 6. Alright. And let's cross multiply. So I've got 25x minus 30 equals 15x plus 3. Am I right? Subtract 15x from both sides, you get 10x. Add a 30, you get what? 33. Did I do that right? Okay, 3.3.
Or 3 and
3 and a third, or just 33 over 10. Doesn't make any difference. I would accept any of those answers. Since it's 10, it's easy just to move the decimal place. But you could, yeah, I could accept any of those other answers as well. Alright? Almost towards the end here. Let's see what we're going to do here. Same kind of deal, isn't it? Alright, so find x. Oh my gosh, this is way too easy. Man, I made this like a baby test. What's going on? You sure this wasn't the elementary school test version? Okay. So look, solve for x. So you set these two equal to each other, right? Because look, this segment equals this segment. That's basic stuff. Alright. I guess I should do it because there might be some people that look at it and like, I don't really see what you're talking about. So we'll do it anyway. So 4x minus 35 equals 1/5 x. We'll write it 1/5 x plus 3. Subtract a 1/5. Let's do this not with mixed numbers. Let's do it improper. So if I put this over 5, what would that be? That'd be 20 over 5, wouldn't it? Minus 1 over 5 would give you what? 19 over 5. I kind of like doing it that way, don't you? Then add a 35 to both sides, and that gives you a 38. The reason I like doing it like that, because look, they rigged this thing for you, didn't they? Do you see it? 38, 19, does that ring a bell? So what I do is I multiply by 19 over, I'm sorry, I lied. Getting ahead of myself. Multiply by the reciprocal, so it's 5 over 19. See? Get rid of this by multiplying by 5/19. Do this. Watch how easy. That's 1. That's what? 2. X is 10. And then that's what X is. Alright? You alright with that? That was easy. Alright, let's do Y. Same exact thing. That's even easier. Should be able to do this in your head pretty much, right? We'll write it out though. 5y minus 8 equals 2y plus 1. Subtract 2y, that's a 3y equals 9, y is 3. Alright. I'm almost embarrassed. That was so easy. Okay. Alright, I'll just give you all the hard ones. Oh, there goes your sarcasm again. What?
How many questions are on our
40. Alright, let's look at this. We've talked about that several times. Okay, WX. Find WX. Is this one right here. Alright? I'll just call that A. Is that alright? Instead of calling it WX. So, what's the deal with this? Oh, okay. Look at this. That's easy, isn't it? I've got a, what kind of a triangle do I have? It's an isosceles triangle, don't I? And I've bisected this. So if I bisect this angle, it's actually going to hit this opposite side. What's it going to do to that opposite side? It's going to bisect that side as well. Okay, really, that's all there is to it. So what's this side right here? It's 14. Okay. To see that they're what was the word I just used? Isosceles triangles. Yeah. Okay, because Yeah, because they would have to be equal. Because look, if this could still bisect this angle, but this side could keep going like this, right? And if I went like this, it would not bisect that opposite side. Okay, but if they're isosceles, then it does bisect the opposite side. So that is important. Okay, YW. Oh my goodness gracious! I should have taken this before I gave it to you. I need to. Well, I mean,
Maybe we'll run a smart thing.
this one I think I already had printed up. So I didn't make it up. Let's take a look at this one right here. It says if the length of scale model. Oh, a lot of people missed this one, didn't they? Because of this. Because this says 9 inches. All right. So watch what it says. What is the scale factor of the model? So I cannot compare this. Watch. I cannot compare 9 inches to 150 feet and then simplify that. Because I can't compare inches to feet. Right. You could do this a couple different ways. You could change this to feet and simplify, or you could change this to inches. I'm going to change this to inches. Excuse me. Let's change this to inches. If it's 150 feet, how many inches are in a foot? 12. So 150 times 12, I don't know. 18 what? 100? Okay. Thank you. So that would be 1,800 inches. Everybody got that? You see where I got that 1,800 from? And now I just simplify this. That goes once, that goes twice, and what is it? 1 over 200. So the scale factor for every one whatever, 1 centimeter, 1 inch, 1 foot that you go on the little one, you're going to go 200 on the actual one. Okay? So that's your scale factor. Now you could have written it 200 over 1. Depends on which way that you're looking at it. I would accept it either way. That's how you do that. And that's, a lot of people left it 9 over 150. But you can't, or they might have even simplified this, but you can't leave it like that. All right, let's do this one. 15, when a 15-foot tall wall, okay, here's the wall, it's 15 feet, cast a 20-foot shadow, so the shadow goes along the ground like this, right? Okay, so that's one building, and then cast a 20 feet, so let's put the numbers in here. So that's 15, and that building casts a 20-foot shadow. Then it says another building, right, casts a 32-foot shadow. So how did I do that? I think, did we put it all on one?
15 over 20
Oh, I know what we did.
equals X over 32.
I think we did this. But I want to draw the picture. Let's see, 15, 20. Then a building, so it's got to be a taller building, right? Would you agree? Cast a 32. So watch. So taller building. So let's do it like this. Let's say the 15 went to here, all right? And this whole building was 32, and it casts a bigger shadow. So the 20 goes to here, right? So you're going to have a larger shadow from a, excuse me, a longer shadow from a taller building. Again, let's say the 20 went to about right here. Okay. There we go. Does that make sense?
Yes.
I think. Nah, you know what I should have done? Let's do it like this. Yeah, you could do 2 separate ones. Is that what you did? 2 separate ones?
That's what.
I just got the one.
I'll tell you what. Let's do it like this. Like that. You could do 2 completely separate triangles, and that would be completely fine. That would be perfectly fine. So this is the height of the building that we don't know, isn't it? That's the taller one. And then this is 15. Well, the 15 casts a 20, right? This one right here casts a 32. So this whole entire thing would be what? 32. Correct? And we're trying to solve for this. Excuse me. So what would you do? I would compare the height of the tall building to the longer shadow, right? Equals the height of the small building to the smaller shadow, right? And you could have done that without the picture. I just thought the picture could be helpful to you, so that's why I drew that in there, all right? And then you just cross, well, you could cross multiply, but since h is already on the top, just multiply that by 32. And you could simplify it in your head, but I'm going to do it on a calculator. 15 times 32. Divide that by 20. And that's 24. So H would be 24. It's supposed to be an H. Alright, so that's 24 feet high is that building. And there you go. That's chapter 7. Okay, now all those previous ones, it's on the it's on one of the YouTube things, so you can look for it. And I did all those just like I did right now. Everybody good? Yeah, that was pretty easy. The next test must have not been that easy because it's the retake. Means you probably didn't do well the first time around, so we had to retake it. So